Did you know Tanzania's population includes around 120 different African tribal groups, and the largest group is the Suguma? Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2, and as for today, we would like to present our case study on the population growth in Tanzania from 1960 until 2020. This is conducted with the purpose of implementing the multi-region model. Let me introduce you to our team members. First up, we have Muhammad IKWAN Adam bin AZHA as the group leader. Next, we have ARIF HAIKAL bin Muhammad AZMAN. Then we have me myself, which is BATRIESYA IRDINA binti KHAIRUL HEZAL. And then we have NAJIHAH binti Isa. And last but not least, we have Muhammad Irfan Rusydi bin RAZALEIGH.
For the introduction, Tanzania is a beautiful country that has been growing ever since 1960 to 2020. With more than 55.57 million people calculated by United Nations in 2016, and has more than 120 variations of African people and expected to reach 69 million population in 2022. However, the population growth rate in Tanzania is far lower compared to world average, with only 3% of population growth rate yearly, and even lower compared to several sub-Saharan African countries. One of the reasons because the infant mortality rate has been diminished ever since 1960, and a lot of migration activities away from the country. Thus, in this study, a growth model called the maturation model is implemented in order to determine the exponential growth and based on population growth and progressing speed. The model was introduced by an English scholar named Thomas Robert Malthus and widely recognized for its application in population ecology and dynamics. Thus, performing it accurately will achieve the objective in the study. Our objective is to compare the population of Tanzania in the past 1916 to 1920, and for the actual data and predicting the value in the 2022. Secondly is to calculating the percentage error for each year and finding the average. And thirdly, implementing the maturation model on Tanzania's population density.
Next, for the implementation, firstly, we need to find the set of data that shows a number between the year 1960 to the 2020. Then, we construct a table by referring to data to analyze the data easily. Then, we put the initial value when t equal to 0 in the year 1960 from the general equation. Then, we calculate the population growth k using the particular solution. Then, we make the graph using Google Sheet by inserting all the numbers from the data to determine the graph shape. Then, we make a graph of particular equation using the graphic calculator Desmos. Then, we make a prediction of one past value to calculate the percentage error and future value of population in Tanzania. And lastly, answer all the questions for discussion of the data. The solution to determine the particular solution, firstly, we let BINTI equal to the number of population growth in Tanzania, and since the rate of growth is proportional to the number of population growth in Tanzania, we can get dp over dt equal to kp. Then, we using the approach of separable variable, we separate the variable p and t, and we get 1 over p dp equal to k dt. Then, we integrate both sides of the equation. We get integrate 1 over p dp equal to integrate k dt, and we get the answer by using the integration properties. We get p equal to exponent kt plus c. Then, the general solution can be simplified as p equal to a exponent kt, where exponent c equal to a. Then, by using the initial condition t equal to 0 in the year 1960 and p is 10,052,151, we substitute into the equation and we get a equal to 10,052,151, and the general solution become p equal to 10,052,151 exponent kt. Next, we need to find k by using t equal to 1 in the year 1962 and p is 10,651,954. Then we substitute into the general solution equation and we get we calculate and get the answer is 0.05796, and the particular solution becomes PT equal to 10,052,151 exponent 0.05796 t.
For the data analysis, we have prepared two graphs. So this is the first one. The graph is plotted by the data that are retrieved from Worldometer website. Then construct a table in the spreadsheet for actual data and the predicted value that were calculated by using the particular solution. Then we can see the two exponential lines that indicate the actual population and the estimated one. We can see that they are slightly different. It means that the percentage error isn't too high. Then this is the second graph. To make this graph, just insert the particular solution into any graphing software. In this case, I chose Desmos. The graph is increasing exponentially and prove that the Thomas Malthus assumption that the rate at which the population grows at a certain time is proportional to the total population at that time, as it is proven to be true for the population in Tanzania. We can use the particular equation to predict future values. Let's say we want to find the number of population in 2022. From the table at the right, we can see the year trend in which is 2 years, the values of t increasing by 1. Then substitute t equal to 31 into a particular solution and we got the predicted value. Since the number of population must be in a whole number, thus the population of Tanzanians in 2022 is expected to be around 60 plus million people. We can also use the particular equation to find any past value within the range. Let's say we want to find the number of population in 1964. By referring to the value of t from the table beside, we know the value of t is 2. Then just substitute it and you got the estimated value. Since the number of population must be in a whole number, thus the population of Tanzanians in 1964 is around 11 million people.
Next is the discussion. Based on the table shown, the predicted values are not accurate with the actual data. This is because the actual data were measured using census to get the actual number of the population. Meanwhile, the predicted values were calculated by analyzing the human population growth mathematically, which is by using the Malthusian model. To calculate the average percentage error, we must first calculate the percentage error for every year by using the formula of actual data minus predicted values divided by predicted values times by 100. Then, after we get the percentage error for every year, to get the average percentage error, the sum of the percentage error divided by the sum of the year, we can get the average percentage error, which is 3.38%. Next, the question is that what has affected the population growth of Tanzania in the past and what might affect the change of population of Tanzania in the future. In the past, the growth rate of Tanzania's population has increased rapidly in the year 1967 to 1978. This is due to the rapid urbanization process. This rapid urbanization process is because of the rural to urban migration, increase in the number of urban centers over space and time, natural urban increase, expansion of urban boundaries and daily commuters. While in the future, the population of Tanzania is predicted to reach 70.1 million by 2025. This high rate of population growth is because of the persistently high level of fertility, reduced mortality and low international net migration.
In conclusion, we have successfully modeled the population growth in Tanzania from 1960 until 2020 by implementing the Malthusian model. We discovered that Tanzania is expected to experience overpopulation in the future due to the increasing trend of population growth. Therefore, actions must be taken to solve this growth problem by promoting family planning to reduce high fertility rates. From this task, we were able to explore and experience mathematics deeper, besides improving our analytic skills and critical thinking into finding solutions and making predictions. Overall, this group project has taught us the importance of teamwork. With everyone's cooperation and contribution, we were able to overcome every difficulties together and achieve success regardless of online barriers. Thank you.